After graduating high school, I attended Pasadena City College. And my goal in doing so was to figure out what I wanted to major in, what career I wanted to pursue, because in truth, in high school, I did not figure that out. I tried so many majors, I took so many courses, and I engaged in every single opportunity that was made available to me. So I took part in many different projects that were completely unrelated, but at the end of the day, my favorite one was when I was working with these morpho butterflies. My chemistry professor kind of invited me to do this project. He saw my enthusiasm for experimentation. How are we getting this color? How does that color change when I change the physical environment? Like if I change the solution it's in, because like if it's flying around, it's in air, but if I put alcohol in it, it turns green. Like, why is that? Or how is this color generated? Well, if I look at the butterfly with the scanning electron microscope and I could go to the nanometer scale, I could see those unique Christmas tree-like structures that allow it to reflect off blue light. If you're like me, a community college student who didn't have a strong foundation in the sciences, like just exploring those different patterns kind of introduces you to the different subjects and fields that you may want to dive into. I was actually working with this postdoc who was kind of using the inherent properties of the morpho butterfly and other butterflies and other structural color in nature to develop these sensors for diagnostic techniques. So now I know that you can apply this super cool phenomenon that I was already interested in studying to medicine and advancing it to unforeseen scales. After graduating or transferring from PCC, I immediately sought out my current advisor, Dr. Pouliakakos, because on her lab website it says nanophotonics for global health, which is literally exactly what I wanted to do. So I sought her mentorship, and I noticed her lab was using these fabricated metasurfaces, which are basically materials with super tiny structures that manipulate light to probe different fibrous tissues to basically reflect back specific colors that correspond to how the fibers are aligned or how thick they are or how densely they are congregated. And I just thought of different ways to draw from the structural color we see in nature to kind of improve these technologies and see how they could be more easily implemented or even better produce stronger signals. And so that's kind of what I've been working on for the past, year and a half. And through this process, I've learned so much about the field of optics. So it's not just I look at things through a microscope. It can be more complicated. There's a lot of physics behind it, not just engineering. There's a lot of science. And when I'm working with actual physicians, actual pathologists, then there's a matter of how do you translate this to someone who doesn't so much have the strongest physical background, or doesn't know what a polarized light microscope is, or doesn't know what Jones calculus is, and just make them want to use what you're developing. So I kind of went from a place where I had no idea what I was doing, and I was just hoping for the best, to just getting really dedicated and into this venture of applying structural color to better advance these diagnostic tools and hopefully make them accessible to a wide range of audience.